Hi, today I will be sharing our work on ISAR, a benchmark for single and few-shot object instance segmentation and re-identification. For the development of effective object-level SLAM and more broadly spatial AI systems, it's crucial to reliably detect, segment and re-identify objects. Achieving this shouldn't necessitate the use of millions of training examples. We have created this benchmark to highlight this issue and expedite research into algorithms for single and few-shot object instance segmentation and re-identification. We propose a dataset and a baseline method to fuel the development of such methods. Our semi-synthetic dataset consists of video sequences and indoor scenes of the replica and the habitat Matterport 3D research datasets, while the objects in the scenes are part of the YCB object and model set. Given a video sequence with one or a few sparse point and bounding box annotations per object in the top row, the aim is to build representations of these objects to then re-identify them in video sequences recorded in entirely different contexts in the bottom two rows. Here, at the top, an annotated video sequence is shown with a single annotation per object. At the bottom, two evaluation sequences with their respective ground truth annotations are shown. The goal is to sequentially reproduce these pixel-wise annotations on the evaluation sequences. Notice that the objects can be dynamic, occluded, and can disappear and reappear from the frame. This is in stark contrast to existing datasets in video object segmentation and video instance segmentation, where A, the object often stays salient in the video frame, and B, the object almost never needs to be identified in another context. In addition to the benchmark dataset, we provide a baseline method. In accordance with the setting of our benchmark, we first start with a sparsely annotated sequence with point and bounding box prompts. We decided to leverage the power of image features from self-supervised models trained on massive diverse dataset. This had a few reasons. It does not require extra training on millions of samples, and it can handle arbitrary object classes, as it has been shown that these models are good at encoding open vocabulary semantic knowledge. As large self-supervised model, we chose the Dino V2 model to extract dense features from the images. The architecture of our baseline method is as follows. First, we use the segment anything model, a promptable instance and semantic segmentation model, to transform the annotations in the images of the train sequence into object masks. After, we extract Dino V2 feature vectors from the entire image. We then use the masks provided by SAM to split the feature vectors into positive and negative samples. Further, we combine the negative features with a large set of Dino V2 feature vectors that we collected previously on random images. Thus, we have a lot of negative feature vectors and a few positive feature vectors. With this dataset of positive and negative samples, we train a linear support vector machine to distinguish between the two classes. One SVM is trained for each object visible in the train sequence. So the decision boundary of the SVM becomes a classifier to determine the instance membership. On each image of the test sequence, we extract the Dino V2 feature vectors, upsample them to the image size, and classify whether they are part of the object or not. Finally, and optionally, we refine the resulting mask, again using the segment anything model. Here are some selected qualitative results of the baseline method. On the left, you can see the training sequence annotations, while on the right, the output of our baseline method is shown on evaluation sequences. While the method performs well in this multi-shot scenario, handling of objects of the same semantic class, of particularly small objects, and temporal consistency could be improved substantially. Thank you for watching. For more information on our research, please refer to our paper. We hope that our benchmark will be adopted by the research community to advance the representations of object instances, enabling a more robust object re-identification and object-level mapping of dynamic environments.